So Jiva, so far our programs have started at the top and finished at the bottom, and maybe called out to a function, but really it's just been straight down now. Obviously life is more complicated than that, and controlling our flow is something we have to do in many things, including our programs. So what are we going to look at around that?
Right. So there are constructs in programming languages that give you the ability to control program flow. That's really what you're talking about when you say, well, you start at the top and you go down and you execute things one after another and stuff like that. That's the flow of your program, the thread of execution through your program. And Objective-C and other programming languages give you constructs that let you branch and loop and take action based off of runtime conditions. And so really that's what we're talking about there. And those fall into kind of two broad categories. The first one is conditional statements, which are things like if statements and switch statements. And remember that ternary operator that we kind of touched on briefly when we were talking about operators. Each of those are conditional statements. And then the second broad category is loops, which are things like things that give you the ability to iterate over something multiple times or until a particular condition is met. So there's things like for loops and while loops and stuff like that. So we're going to discuss both of those. Probably the best place to start is to look at conditional statements.
Okay.
Now, the first thing to know about all of these statements is that, when we've been dealing with most of the statements that we've seen so far in this program, they've been what are called simple statements. So, if we go back and we look at just our plain old main, that we get from our template code, if you look at this nslog statement here, it's going to print out this nslog and it has a semicolon at the end. And that's important. The semicolon always occurs at the end of a simple statement like that.
Right, okay.
But there's another kind of statement, which is called a compound statement. And actually, these functions, for example, is an example of a compound statement. So it's one of these cases where you have the statement and then you have the curly braces that indicate the scope of that statement's body, right? And if statements or conditionals and these program flow control statements are all compound statements. So you don't have to have, the reason that I'm making this distinction is compound statements don't always have to have semicolons after them. So when you're looking at an if statement, for example, you won't necessarily have, if you look at that function that we were just looking at, you'll notice there's no semicolon down here at the end of this curly brace. That's because it's a compound statement, and you don't need a semicolon there.
Right, okay.
Okay. So it's an important point to remember that. We'll come back to that. I think that's something that catches a lot of new programmers is, they don't always know where's the right place to put that semicolon. And the answer is you put it at the end of simple statements always. And then there are certain cases with compound statements where you'll put it as well. We'll discuss those. But for the most part, for compound statements, you leave off the semicolon.
Okay.
So let's take a look at the if statement to start off with. So I put this sort of template up here to show kind of the basics of what an if statement looks like. Now, this is the simplest kind of an if statement. Essentially, an if statement consists of the word if, then a conditional statement inside of parentheses. Now, the conditional statement is going to be checked by the runtime, and it's going to say, does this conditional statement, whatever it is, does it evaluate to true or false? If it evaluates to true, then the statements that come after the if statement are executed, and if it evaluates to false, it skips on to the next section of code after the code block that's part of that if statement, after the conditional code block. Now, in this particular case, again, this is the simplest kind of if statement, and this is basically showing just you've got if, conditional statement, and then this statement will be executed if the conditional statement evaluates to true.
Okay.
More often, you usually won't see it written like this. Usually, more often, you'll see it written something like this: conditional statement, and then enter, and then you'll see a statement here like that, right? Usually indented. That's perfectly okay as well. And probably the most frequent form of the if statement will be something like if conditional statement, and then curly braces, and then a series of statements in here.
Right, so that's basically saying if the condition is true, run all of these statements in the next block of code, which is defined by the curly braces.
Exactly. And if the conditional statement evaluates to false, then it actually jumps down here and starts executing. You know, you might have more statements down here that will be executed. Now, if the conditional statement evaluates to true, then the interior statements here will still be executed, and then it will continue to execute these down here as well. But if the conditional statement evaluates to false, then these will be skipped and you'll go right to that statement right there.
Okay.
Make sense?
Yep. Makes loads of sense.
So let's take a look at some of the actual code examples that I've got here. So the first one, I just made this little function here just for the sake of example purposes, right? You know, we have this variable that's passed in. It's called x, and in this first case, this is exactly the kind of case like we saw in that first example where we're just doing if conditional statement. And so what we're doing here is we're saying if x is greater than 10, then we log x is greater than 10. Very simple, right?
Okay, yep.
Second example is that same kind of thing, but on the next line, you know, where we were showing that, where it's, again, if x is greater than 10, then we log that it's greater than 10. And then this third example, same kind of thing. Just like we saw before with the curly braces, it's going to log that it's greater than 10 there. Now, the if statement also has a companion statement that can be used with it called else. So what you can do is you can say, if conditional statement, execute this stuff in a block, but if not, else, execute this second block of code. And that's what we've got an example of here. So here we see if x is greater than 10, right? Then we log x is greater than 10. So this code here will be executed if the conditional statement is true.
And again, that's blocks as a block of code, so that could be lots of lines of code if we wanted to.
Absolutely. You can have as many statements in there as you want. In fact, you could even go out and call other functions or methods or all kinds of stuff. Else, so in other words, if x is less than 10, then we execute this block of code, which says x is less than or equal to 10.
Okay.
Which is, now, I mean, that's an important point just to make a note there. The condition that we're checking here is x greater than 10? So in fact, if that evaluates to false, then we know that not just is x less than 10, but it could also be equal to 10 as well, right? Because it's not less than or equal to 10, it's not greater than or equal to 10, it's just greater than 10. Make sense?
Yep, perfect sense.
Okay, so that's how you use an else block, right? Now, the else always has to have an if associated with it. You can't have an else just by itself, because what would you else against, right?
Doesn't make any sense, no.
Exactly. But this is all still considered to be all part of the same compound statement, okay? Now, the next thing to look at is a little bit more complicated. We come down here and we say, if x is greater than 10, then we do this first thing here with the x is greater than 10. We print that out. But now we've got this new thing here, which is else if. It's another one of those sort of negative conditional statements that we can use, where if the initial conditional statement evaluates to false, then we're going to come to this one and we're going to say, well, in this particular case, because it's an else if, it's going to say, well, the first one failed, so now else, if it's true, if this new statement is true, then we execute this code in here.
Right.
So we say else if x is greater than 5, then we print out this statement here, x is less than or equal to 10 and greater than 5.
Right, okay, yeah.
Right. And then finally, we still have our else block on here in this particular case, where if it's less than 5, but less than 10, then our else statement will still execute. So you could have lots of these. You could have if, else if, if greater than 10, else if greater than 8, else if greater than 5, else if greater than 4, and you could chain these all you want. Having the else at the end of it is also optional. So you don't necessarily have to have a sort of a default condition there of else, this is the final result. If all else fails, then then that's what that statement's there for. But that's optional. So in other words, I could take that out and I could have just if x is greater than 10, else if x is greater than 5, and that would be perfectly legal as well. But having the else on the end of that gives you the ability to say, again, like I said, if all else fails, this is what we're going to print.
Okay, this all makes a lot of sense.
Now, there's a couple of things here that I wanted to touch on also, because they're kind of common errors that occur when you're dealing with if statements. One of them is, for example, you can use any of those operators that we talked about previously when we were talking about operators in these conditional statements, in the if statement, right? So you could use if x is equal to some value, right, using the double equals operator, right, that we've got right there. Mm-hmm. Alternatively, you could say, if x is greater than or equal to, and so on and so forth. But because you can use any of these statements, you can even use, for example, calls to other functions. So you could say here, this could be something like if my other function, like that, right? If that function returns something that evaluates to true, then the same thing would happen. It would do this if, it would do the true code block, and if it evaluated to false, then it would do the else, right? But an interesting point here is, because you can use all of these different operators in here, it's also perfectly legal to do something like this, where you do if x equals 10 instead of doing x equals 10, right?
Right, okay, but that means probably not what you initially think it means when you look at it.
Exactly, because what it actually means, this is a common error, because people think, equals, it actually means is equal to, but in fact it's the assignment operator. So what will actually happen here is it will assign the value of 10 to x, and then the code for the compound statement will basically always execute, because that'll evaluate to true.
Right.
Now, there are some cases when you actually really do want to do this. For example, if there's a case where you wanted to, if you wanted here to call some other function, right, and have the return value of that assigned to x, and you also at the same time want to check to verify that whatever it was that was assigned to x evaluates to true. In those cases, because this is such a common error, just doing this like this will generate a compiler warning when you run it through the static analyzer in Xcode.
Right.
But you can make it so that it doesn't by actually enclosing this whole bit right here inside another set of parentheses. So essentially what you're doing there is you're saying, do this thing first inside the parentheses. Remember, we're kind of working with that order of operations, right? Do this thing inside of the parentheses, and then whatever that's evaluated to, in other words, what's been stored in X, I want to check that for my conditional statement before I go on to the next bit of code.
Right. Okay.
So there's times when you do want to do that. We'll see a couple of examples of that when we start into the object-oriented programming, because there's a common design pattern in creating initializers for objects where people write their code exactly like that, and they really intend to do that assignment and then check to make sure that the result is true.
Great. Now, something that just strikes me from looking at this is it's not always as simple as I just want to make sure one thing's true. Maybe sometimes I want to make sure two things are true before I run a piece of code, or three things.
That's true.
How does the if statement support that?
Well, you can also, of course, you can chain your operators together here. So you can do things like, you can do if x is equal to 10 and x is less than 100, or let's say probably a more logical example would be y is equal to 100, for example, right? You could do something like that. And what basically happens here is it's going to evaluate each one of these conditional statements. And in this case, using that double and operator, it's going to and those results together and evaluate that to see if that's true as well. So you could do things like that, where you do the if x is equal to that, or you could do like is x greater than 20, or x is less than 5, for example, right?
Okay, now in those two statements there that you've just done, one of them you've put both the checks inside their own parentheses, and the other you haven't. Is that just to why?
Well, so I kind of did that on purpose in that for me, now I look at this, for me, I hate having to memorize tables of orders of operations, and I can never remember what the order of operations is going to be. It's going to evaluate everything inside of this conditional statement according to that order of operations table that we showed when we talked about operators. So you could do something like this perfectly fine, because the greater than and the less than symbols are going to be evaluated first, and then the or statement or the or operator between those is going to be evaluated after that. So that's perfectly logical. For me, however, I kind of like to have the extra parentheses in there because I feel like it makes for clearer code. I don't have to, maybe it doesn't matter in something as simple as this, where we've got this greater than and less than symbols. But if you've got something complicated going on with lots of, exclusive ors and bitwise shifts and all kinds of things like that, it can be difficult to remember what the exact order of operations is.
So the parentheses is because they come high up the order of operation, it's forcing the things between them to be evaluated as a group together.
Correct. The parentheses are at the very top of the order of operations table. So I like to put in extra parentheses. In other words, parentheses are kind of free syntactical sugar that you can kind of sprinkle into your if statements wherever you want. And for me, I like to have that syntactical sugar because, again, I'm writing for myself 6 months from now.
Right. Yeah.
So that's if statements pretty much in a nutshell. Now there's the second one that I wanted to talk about is the ternary operator, which we again looked at briefly when we were looking at operators, right? But I wanted to really kind of go into a little bit more depth with that and just talk about how exactly it works. Essentially, the ternary operator consists of this question mark and colon combination. Those two together work to make the ternary operator statement. And that's what you use when you want to do something where you want to do something like an if statement, and you want to assign the results of that if statement to something else. And you want it to be short and to the point. In other words, you could do something like with an if statement. Well, let's take a look at this example of the ternary operator right here. Basically, what we're doing here is we're saying if x is greater than 10, that question mark shows us that it's a ternary operation. Then we return 10. That's what happens here. So what we do is we evaluate this conditional statement. If that's true, then the result of the ternary operator is the first statement after the question mark. Else, that's what the colon is for, it's the second statement after the question mark.
So we could have written that code as if x is greater than 10, return 10, else return 20.
Right, exactly. We could do if x is greater than 10, return 10, else return 20.
Now, we didn't need the curly brace blocks there because we only had one line of code in each section.
Exactly.
And it will run to the statement terminator.
Exactly.
Okay.
So if we did that, right, as you can see, this is, quite a lot more code than that is. Sometimes looking at the ternary operator, or sometimes working with the ternary operator, is a lot more concise. It gives you, it's a lot easier to just say, oh, okay, if it's greater than 10, I want 10, otherwise I want 20. It's a nice, terse, one-line statement. Mm-hmm. Now that said, for me, again, I like syntactical sugar. Well, you know me, I like lots of sugar.
You do.
So with to me, I look at the ternary operator, and it's terse, and it has its place, but I find it kind of hard to read. Mm-hmm. So again, your mileage may vary. I personally would probably wind up writing this code because I find it easier to read. I know it's very clear. If x is greater than 10, return 10, else return 20. Whereas with this, I have to look at that and I think, question mark, colon, what is this? And it just, colons and semicolons blur in my mind, and it's hard to pick it out and stuff like that. So the point is, choose the one that you're the most comfortable with. Choose the one that makes your code clearer. They both have their purposes.
Okay.
Now, the last one that I wanted to talk about is the switch statement, which is useful in cases where you have a very simple thing that you want to do sort of a complex selection on, okay? For example, let's say that you had a state machine, and you wanted to have this state machine do certain things based on the current state of that state machine. In that case, you might have something like, let's take a look at an example of a long if statement where we could do something like that. We might have something like void my function. So we have this state coming in, and then we'd have to do if state equals state 1, then do state 1 thing, right? And then else if state equals state 2, then do state 2 thing.
And so on and so on and so on and so on and so on.
And you wind up having this thing that is sort of this long chain of if, else if, else if, else if, else if. And it gets a little, some people don't like to see those kinds of things. Again, it comes back to that kind of readability question. You're writing code for humans to read. And sometimes that long if else statement can be confusing. So the switch statement allows you to do this in a little bit more terse manner, a little bit easier to read manner, in that it gives you the ability to basically say, I want to switch on some conditional variable. Now that conditional variable has to be an integer. It only works with integers.
Right, okay, so if we're trying to reflect on state 1 had been a string of some form,
right?
Which we haven't really dealt with strings yet, but I just assume for the now that we can. Right. It's not going to work in a switch statement.
Precisely.
We were going to do if, else if, else if.
You're going to have to use if, else if, else. Right. Yeah. So the switch conditional variable has to be an integer. Then it gives you, so you have this switch conditional variable. Then it's got the code block specified again in curly braces. And inside of that code block, you have case blocks. And each one of these case sections gives you the ability to say case and then some value. And what it's going to do is it's going to say when the conditional variable is equal to this value, whatever is specified on the case line, then you're going to execute the statements after the case statement until you either reach a break statement or until you reach the end of the switch code block.
Right, okay. It's got you in there, isn't there?
Well, yes, and so there is a gotcha there in that. Well, we'll come to that in just a second. We've got some code here that actually demonstrates.
I'm looking for problems. All right.
So you've got the. So again, I just wanted to make sure that this is clear in that we have switch conditional variable, then we have case constant value. So the constant value will be evaluated against the conditional variable if the conditional variable is equal to the constant value. Now, after the case statement, we have a colon. Then the statements that are executed for that case statement. each one with a semicolon after that. Then a break and a semicolon. That break is optional, which is what you're getting at. And then there's this default statement. So if none of the case statements are evaluated, then the default statement will always be evaluated.
Right. Okay.
Okay. So let's look at this let's look at an example of this, and we'll touch on what you were getting at there. So here again, here's my function. I'm passing in this state variable. It's an integer, so that's perfectly fine. I can use that in here. Then I do this switch on that state variable, and it's going to evaluate. And if the state variable is equal to 1, then it's going to do state 1 action, and then it's going to break, which means that it'll do this, and then it'll jump down to this line right here.
Yep.
Same thing here. If it's a 2, then it'll do this, then it'll jump down to here. Now there is the gotcha that you were talking about. Case 3 here. If it's a 3, that break statement is optional, like I said before. So if it comes to state 3, it'll do state 3 action. But since there's no break here, it will continue to execute until it reaches a break or the end of the block. So in fact, what it will do in case 3 is it will do this statement, then it will also do the default action as well. So now there's some cases where you may want that to happen, where you want it to do action A and then still do the default action. But usually, I think, generally speaking, you're generally going to have a break statement after each one of your case statements so that it's a little bit clearer. So I'm going to do this, 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 or this, essentially.
So, for example, in case 1 there, if the break was missing because I forgot to put it in, and the value was 1, it's going to do state 1 action,
right?
And then it's going to do state 2 action,
right?
Then it will stop because it's hit a break.
Exactly. It'll do exactly that.
So often if you find your code's not doing what you think it is and a switch statement, you might have forgotten the break.
Yes,
I know I forget them all the time.
Yes.
Now, can we have multiple statements in there? Do we need curly braces for multiple statements, or is it just going to go because if we're using the break syntax, it just keeps going no matter how many statements you put in?
Because we're using the break statement in there, you don't have to have curly braces inside of the case block there. You've got basically the delimiters of the code that comes after the case is the colon at the end of the case and then the break statement.
Right.
So that right there is going to be what's going to be executed for that. So the answer is no, you don't need to have curly braces in there. Now, there are some caveats with switch. Well, there's good things and there's bad things with the switch statement. First of all, because what you're evaluating is really simple, right? It's just checking this value against each one of these conditionals. There isn't really any ability to do any sort of, greater than or less than or anything like that. It's very simplistic. Because of that, some compilers can optimize the switch statement a little bit better than it can an if and an if-else statement. So in those cases, the switch statement can actually be a little bit faster. But the problem, one of the complications is, well, like I said, it has to be an integer for your control variable. Secondly, another thing that catches a lot of Objective-C programmers is you get used to kind of declaring variables anywhere you want, right? So in other words, I could declare a variable int. Well, I might want to here inside of this case statement say int x is equal to 50 there, right? That's not legal inside of a switch statement. You can't create a new variable inside of a switch statement. So if you wanted to do that, you would actually have to put that variable up here, or at least put its declaration up here, and then do something like x is equal to 50 there.
Okay.
So switch statements can be faster. They can be a little bit clearer, but they have some restrictions on them, and it's because they're trying to optimize these things for the compiler, and there's the compiler is able to do these optimizations because it's that kind of simpler kind of construct. Now, one other thing that I wanted to mention about case statements is that, or switch statements, is that I said that the control variable has got to be an integer. And that's true. But one of the interesting things about Objective-C, because it comes from C, is that characters, there's a certain data type called a character, a char, right? So you can call char X, right? And you can assign that to a character value like that. What that actually winds up doing is it takes the ASCII integer value of the character G and assigns it to that char variable. So in fact, actually, chars are actually ints. They're just they're just a different name for an integer. So you could actually use characters in here, just single characters. You can't use whole strings.
You couldn't use a whole string, though.
You could use characters in here. Now, again, these are something that probably, if you're doing a lot of C programming, these are constructs that you would use more than you do necessarily in Objective-C. You use switch here and there, but you're generally going to use it in cases like this where you've got, integers or you're working with, state machines and those kinds of things.
So we've seen the switch statement, the if statement, the ternary statement. Is there, and you've touched on some of it in some areas, but what general guidelines should we be using to choose which one to use, or is it just personal taste? Is it?
Well, like I said, the switch statement, there are cases where the compiler can optimize that, make it a little bit faster, make it a little bit tighter, make it a little bit smaller. So in cases where you really have to squeeze as much performance out of a particular conditional as much as you can, the switch statement may be appropriate. Personally, I find that I prefer to use if-else statements over switch statements because of the fact that I don't like the restrictions that switch statements give me. I don't like the fact that that I have to use integers for the conditional variable. I don't like the fact that I can't declare variables inside the case statements, stuff like that. In an if-else statement, I can put anything I want, and it's awesome, right? Most often, when you're working with Objective-C, you're going to wind up doing things with objects in your if statements anyway. So I find that I use if-else blocks most often of these three conditionals. There's cases though where, for example, you want to, the ternary operator is nice and terse, so that's a nice case to use the ternary operator. And there's also cases where the switch statement will result in faster code. As usual, when it comes to thinking about faster code and optimization for memory or speed, probably the best thing to do is to measure first and then determine if that's what you actually need. Because 9 times out of 10, you'll find probably the if statement's fast enough, and that's not where your problem lies. It's usually someplace else. It's like that old carpentry saying, measure twice and cut once. Same thing goes for performance optimizations. Measure your code. And if you really find that, you're executing that if statement 50 bajillion times in your code and optimizing it with a switch versus an if is going to make that much of a difference, then go for it. Otherwise, I would say really just focus on what makes the code most readable.
Great. So that's conditionals. We spoke at the top of the section about loops.
Yes.
So we'll let people take a break, and when we come back, we'll look at looping and iteration.
Perfect.